Hello, folks. How's it going? I should change this. This isn't the tired stream anymore. I mean, it is because it's early in the morning, but it's not as much tired stream. I'll give another couple of seconds for people to show up. I'm going to make another tea while we wait for that. Okay. This is a programming stream, yes. So the state of the situation is, last night I reverted some of what happened in the previous stream because I realized that that approach was not going to work because the features of the language make it not a good idea. And the thing that wasn't a good idea was to try to set up this types block in a format so that it was always frozen for any given family of polymorph instances, right? And the reason that doesn't work is because you can bake parameters of functions that were not polymorphic initially. So, or, you can take a procedure that is polymorphic and fill in all the variables so it's not polymorphic anymore. And then you can bake additional parameters after that, right? So the types blocks inherently need to be able to change in size. And I forgot that when I was doing that work, even though it should have been obvious. So I backtracked on a little bit of that. And last night, in that 45-minute stream, the point of that was to just figure out what the new way was to go. And I just sort of figured like, okay, so we're going to do a hybrid approach where, the stuff that we did earlier yesterday involving making sure that we know the type parameters of the procedure at parse time, that's still totally good. So those are still going to be at the beginning of the types block and in order and all that stuff. And I'm just going to do a thing where, okay, when we're comparing those, then there's a siren going. It's really loud. Oh, I have a window open. Let me close the window. Okay. I don't usually stream with a window. So it's going to be a very easy and fast comparison right now when we just compare the clearly known polymorph parameters. And then when we get to value bakes, we'll do like a slower comparison, but that should be fine. I mean, none of this should matter too much. Maybe I just shouldn't bother and just write the slow, simple version to start with. Maybe for robustness' sake, I will do that. Because worrying about n-squared operations and stuff doesn't matter when n is like 3 at most, which it will be most of the time. I'm sure somebody will come up with a pathological code base where there's like 40 polymorphic variables and stuff. But even that is not going to be very slow because computers are fast when you program them in a fast way. So maybe I should do that initially and keep that working as I then go and combine these. So the thing that I did in last night's stream was I took these, so my high level goal is to make it so that we treat value bakes and polymorph type matching bakes as the same thing. We don't have to do this weird two-phase option when we're baking values and stuff, and that'll simplify the code tremendously. And so to do that, part of what I did last night was I factored these two things so that they're contiguous in the code now. So if we're doing the argument bake, then we look for a matching polymorph here and return a match. And if we're doing the value bake, then we look for a matching polymorph here. Okay, so now this is still a two-phase thing, and we call this routine twice in some cases. And some cases hit this one, and some cases hit this one. But now that these are contiguous, it shouldn't be too bad to factor them together. And then maybe this isn't the only obstacle, but hopefully eventually then we can only call this routine once and have it do both things, right? And that'll reduce the number, or I don't really know if it'll reduce runtime cost in most cases. In some cases it will, but it should make the code a lot simpler and easier to edit in the future. And that's really my goal. That is really my goal. Okay. So, maybe what I'm going to do is I'm going to go to find matching polymorph, and I'm going to, in some sense, right, it's this version, because this is the struct version and this is the lambda version. So, okay, so what I was going to say is we should drop it back to the dead simple version. That's ostensibly slower, and just keep it that way while we do all this other code merge, and then we can make it fast later. And then we don't have to worry about all this other stuff I was talking about keeping the certain parts of the types block in a parallel format with each other and stuff. Although the fact that we're doing that can be exploited later once this is all working again to keep it a little bit faster than it otherwise would be. Okay, so the one thing I wanted to do is I realized, we've been doing all these edits, and part of this, the point of this whole system, of this fine matching polymorph thing, is that it's an optimization that we don't keep, if we want the same polymorph of a function, we don't keep generating it every time. Now, because that's an expensive operation. So what I realized is if that optimization fails, then we won't notice because the program will still run. It'll just be doing more work to compile the program. So I'm just going to go in, I'm going to hack this right now because I don't want to go edit the thing. And just every time we match a lambda polymorph, I just want to print this info out. And so then we can actually see to what extent that's happening, right? So let's, I don't remember in this program exactly which things should match. Okay, so we're definitely matching in a bunch of places, right? So that's good. It means that we're engaging in this optimization many times, right? So if here, for example, right, we're calling array add with a float many times, like 5 times in a row or whatever. And every time that we do that, well, here, etc., we want to use the one generated by this first routine that called it on 123.4.56 minus. Right? So instead of polymorphing it 4 times, we only polymorph it once, and it's good that that still works, because that's the whole point of half of this complication. Optimization always makes your program more complicated. Okay, so that's good. So let's go to types blocks match, and we're going to replace this with the absolute dumbest n squared version. This is the absolute dumbest n squared version. Okay, so here's what we do. For every member in A, we get the declaration A. We say auto db equals find in block. Is that what it's called? Find in block. Yeah, interp name, yeah. Interp a identifier name. Well, it's DA identifier name and the block. And block B. If there's no such member, which may happen if we have a bake in one and not in the other, then the blocks don't match. Right? So that's fine. Otherwise, now we have 2 declarations with the same name. Well, let me just paste all of this up there, and then we'll selectively edit. Okay, if they're both unbound, then we don't fail yet because they match, so we go on to the next member, right? And I'm going to edit this I'm just going to call that new version because we're going to edit it to handle both. And we're not. Well. Yeah. So then we get rid of this. So basically, well, no. Well, okay. So I think, the whole need for this is unbound types block binding. Let's look at that again. Right, so this says nothing about what the expression is. I want to know if the expression is set to null. Okay, let's just make this work first of all. So we're going to make it like the old code, and then I need to figure out, I want to simplify this one thing, and we'll talk about it when we get to it. Okay, so, this return true was wrong anyway. This was a bug. So if they match, we should continue because we have to test the other things. So that is garbage. You don't return true for one single argument. What was I thinking? All right. So we're going to simplify this part after this works. So this should, in theory, work. So we basically n squared. The reason it's n squared is for every member, we're potentially iterating over everything in the other block to find it. There's no hash tables in these blocks or anything because the blocks are usually small. As in general optimization, at some point in the future, we might do something where we I steeped my tea for too long. Where we optionally make a hash table in the block. We don't do that now. Oh God, okay. I got to remake this tea. This is bad news. Okay, so in theory, if I didn't totally screw this up, this should still run and work. So let's try that. Let's see if it even compiles. C++. Look at how long this is taking. Like, what's even happening there? It was like 8 seconds or something. Okay, so that worked, and it looked like it still printed out all the infos. Let's run Sokoban. I didn't do Sokoban last time. Look at all those matching polymorphs. Look at how many we're not generating because we don't need to. Isn't that great? And that still runs. Oh, well, so this is a long-standing bug in Sokoban, that there's some kind of mesh corruption bug. So this isn't due to anything we're talking about, but sometimes some triangles go like off to somewhere very far away. So I need to debug that. I'm like stomping memory somehow. It's kind of fun to watch sometimes. All right. All these cables from my live stream last night are getting everywhere. I had to move stuff around for the special Nintendo stream. Okay. Okay. So that's good. Now, in theory, oh, I was going to simplify this now. So I just want to assert, I'm going to assert that this is equal to null, and I think that assert's going to trip. Because I think it's not equal to null ever. I think I set it to like type def poly use or something. And so I just want to be uniform about that then. If I, okay, wait. I am uniform about it now because if a bake hasn't been baked, it's not in this block at all. So anybody in this block is going to be bound to an expression if this is. So I'm just going to, this assert is probably going to fire, and I just want to know that doesn't fire. Okay. Okay, so unbound types block bindings have an expression value of null, which is okay. I don't think I'm worried about that. In fact, that's probably cleaner than setting it to anything. I just wanted to know. All right, so this case should not ever happen anymore because the way that we're doing things now, like I just said, if value bake arguments are not baked, they shouldn't be in this block at all. So I'm just going to assert false here. If that fires, then we have to debug something. It's not firing on Sokoban though. Let's run that. Okay, still running. And it's not firing there. So that's good. That means we can delete this whole thing. Okay, so this has turned into a, you know, when code doesn't have to be fast, it can be simple, right? And that's good. So this is simple. We're just saying, okay, for every declaration in A's block, find the one with the same name in B's block. If you can't, then these blocks don't match. If they're both unbound, then they match, and we continue on to compare the next thing. If one is bound and the other isn't, you know, these are now equivalent tests. So yeah, you know what? This is wrong now. Who else calls if is unbound types block binding? Is unbound. Well, that's commented out, right? Okay, so we won't delete that routine yet because we're using it in a few places, but it is equivalent in certainly in this case and probably in all cases. Did I put anything on here? I'm going to say incomplete, I believe is unbound types block binding is now equivalent to just asking whether decal expression is equal to null. If so, we don't need this routine. You know what? Okay. I'm going to check in here. We're going to do our baby step and check in. And then I'm going to assert that the expression is false here when I return true. And if that works for everything, then I will just change this expression to that. Okay. It's all good. Sometimes I wish I wasn't printing out those polymorph matches, but okay. Simplified types block matching checker, not fast. Okay. So let's do that. We're going to go here and we're going to say assert decal expression is equal to, see? It deleted the whole return. Like Visual Studio, they're so dumb. Well, maybe that's not the right thing to say, but I just can't believe they put in quote unquote features like this auto punctuation thing that I don't even want, and then those things like destroy your program. It's so bad. I actually one time had something that still compiled correctly after it did that, because it was a function call, so it was like the function name open paren and some expression, and it deleted the function name and I didn't notice. So the program still compiled and ran, but like had a bug in it now because it deleted the function name. It was ridiculous. Oh wait, I don't want to run this from the debugger. I don't like to do that. So let's just see if that assert fires. Does not appear to be firing. Okay, so we're going to say at cleanup, this is maybe a useless abstraction and should be removed. And I'm going to say decal, I'm going to say return decal expression is equal to null. Much simpler. Much simpler. So that test that I did of putting that assert there is not, mathematically speaking, 100%. The thing that I didn't, I said, okay, assert that the expression is null if this other stuff was true. I didn't test in the other direction that expression is not null otherwise. And even if I tested that, I still didn't prove that this gets called with coverage over every types block binding during the program. But because of my existing knowledge of the system, I have reasonable confidence that those things that I did, well, oh, you know, okay. What's happening is this is being called in some contexts that I did not expect, so maybe I can't simplify it that way. Yeah, I mean, this is getting called, okay, this is nonsense, actually. This assertion, this is probably a really old assertion that doesn't matter. So, right, okay, so I'm calling this basically on every declaration that exists at top level, and no declaration that exists at top level can possibly be a types block binding at all, because top level scopes aren't types blocks, right? So this assertion probably went in when I was initially putting in types blocks and I was a little nervous. Now the transition that just happened was that old expression that was here would only ever be true in a types block, right? Whereas this new thing, there are declarations with expressions that are null that live in blocks that are not types blocks, and since this is calling it for everything, it's hitting that. But I think, you know, I want to go toward removing those fields that I was testing, and so I'm going to do a thing here where I assert decal enclosing scope. I just want to make sure that I only call this from reasonable places. And assert decal enclosing scope block type is equal to block types, right? So, and then I'll delete this one. I guess I don't trust that, but whatever. Okay, let's see where we call this from. Okay. Yeah, okay, you know what? I do kind of want, all right. So I was trying to simplify this too far. So this procedure was originally meant to answer the question, is this in a types block and is it unbound? And the answer that, and what I was trying to simplify it to was like, if the caller knows this is already in a types block and calls us, is it unbound? And those are two different things, right? Because it's being called for things that are not in types blocks. So instead of asserting this, I'm just going to query it, right? And I don't want to dereference the pointer if I don't have to. So I'm going to check the expression first. I'm going to say if the expression is not null, return false, it is bound. Otherwise, return this, right? So if the expression is null and it's, well, let's assert the enclosing scope. If the enclosing scope isn't set, we probably shouldn't be calling this routine, although maybe that happens. We'll see. We'll see. Maybe that happens. All the wording. Ah, it does happen. Why does it happen? Oh, because we do it in the, all right. Things are complicated. So we're inferring a type instantiation, and we've resolved the declaration, but resolved must, really? Wait, what? It has an enclosing scope. What? How did that not compile correctly? I think it just didn't compile. It had an enclosing scope, man. What are you doing? Sometimes I magically solve every problem that jumps up, but it depends on the complexity of the program. And part of what's happening here especially is that I have not worked with the polymorphism. No, it's really asserting. What is going on? Okay, wait. Decal, no, oh, let's, okay. Never mind, that was not, okay. I hit an old breakpoint that was there. It was not the assertion going up. So now, okay, so we're checking for naked SOA. You know, okay, so the thing is, SOA, the old SOA is deprecated right now. So whenever I hit anything like this, because SOA is going to be replaced by something better later on. This was breaking the new types block changes I'm trying to make. Since SOA is currently deprecated, waiting for the new feature. Now, like this whole call, this is just to hunt down certain erroneous ways of declaring SOA things that you might do in your program. And that's, I think, not going to have an equivalent in the future version anyway. So we're not worrying about that. Okay, so there we go. Both programs seem to compile. Okay. We've still got our rogue polygons. It's funny that it's often the same ones too. So that's going to be fun to debug. Okay. So this is good. This is good. Good, good, good. So the nice thing is we didn't use that field. Actually, what was it called? These two fields. So I think this one we never used and can get rid of. For polymorph value bake. Okay, we set it, but we never use it. I'm not going to delete it yet because we might want to use it, but in theory, we can probably get to a point where we can remove these fields, and that would be good. So we just removed one dependency on those fields, which was, this routine that we were just editing used to use them and now does not. So that's good. It's a constant, you don't want your data structures to get increasingly crufty over time. So you kind of have to engage discipline and say, like, do I really need this, right? And one direction I could go in terms of polymorph cleanup, and maybe this is what I'll do now, is I want to look at that field and figure out if it's really needed anymore. Because if it's not, that might be another, it's not the big simplification that I'm shooting for, but if it's a small simplification, it'll make all the different pieces of the code just, a titch simpler, and that helps make future work better. But in the meantime, I'm going to check in the baby step that we just did. What do we say? Simplify, what was that called? Is unbound star. What is a types block? I explained that a bunch of times in yesterday's stream. It's one of the scopes that a Lambda has where when you polymorph, when you specialize a routine, the definitions of the variables that specialize it live in the types block. That's all it is. Okay. Let's do that search. Let's see what we use this thing for. We sure do use it a lot. Although some of these are just copies. All right. We set it, we define it. Oh, there's one in the type definition as well, which is interesting. This might be the one that's actually important. So this is using the type definition one, which is maybe an orthogonal issue. No, it's not an orthogonal issue. Okay, you know what? I believe we need that. Right. We need that to do the type matching when we're polymorphic. Yeah. Like here. When we do the variable matching, we need to be able to have a pointer back to the thing. That's how we do variable matching, I think. Wait, where are we? Okay, this is just type checking. That's not... Okay, that's not what I'm thinking of. Yeah. Okay, so we use that here. So when you actually match a procedure that has polymorphic variables in it, it goes through the regular type matching system, which is part of which we're looking at now, a very small part of which we're looking at now. And that system you know, uses what's stored in this pointer now, so that's fine. It uses it to know what's matching, right? And the thing is, if that's what it's being used for, then we do not need an equivalent for value bakes at all. So maybe I can remove that field because value bakes don't happen via type checker matching. They happen sort of at a different time. And at the time when value bakes happen, which is regular procedure call time, because you're calling a procedure, you just have, you know the arguments and return values, and it's not really a recursive check that is lacking context like this is. So I think this field stays for now. We don't try to remove that, but we do, value bakes do not use this field. It is here to, it is here so we can copy it to the type definition so that it can be used in check.types match to bind expressions to polymorph variables, type expressions. Okay. Now, hopefully, that field is not being abused. Yeah, this is all filling in matches. Okay, so why? Okay, that's just a check. what's happening here. Yeah, I don't think that's relevant to what we're doing. Okay. So we've deleted the other fields, so now someone's initializing that, I think, so that we're going to get an error when I try to compile. Yeah. So let's get rid of that. Okay. It still compiles. That still compiles. Okay. So now I need to figure out, okay, what's my next step? What is my next step? And I don't mean the next step operating system or whatever. Was next step the file manager or the operating system? Anyway. Okay, so I feel like hitting this now in some way. I think we can just do this for both cases now. I think, so let me go back a little bit and look for when I use the value bakes, right? So here, earlier in the procedure, this is line 552, and here we're at 581. So this is where we apply the value bakes to the lambda, and they go into the type block. So now I believe that both of these can be factored together. So I believe I can just comment this out, and I can get rid of the case checking on this and just do that. That would be nice. That would be nice. Nice. Who knows if something bad is going to happen. I'm going to hit enter. Oh, ho, ho, ho. Ho, 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 ho. Ho, 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 ho. Nice. All right. So now, okay. When we had a separate hard code for value bake, we did a rollback here instead, but maybe that is cleaner, or maybe we want to get rid of the concept of rollbacks altogether eventually. So I'm just going to put that there because, like, this just has to do with, this is doing what this is doing, or no, whoa, no, don't put that in the wrong place. It's doing what these are doing, and that just has to do with things, you know, being in the queue of being compiled, right? So what happened is they got to a current stage in the queue, and we're doing polymorph stuff, or actually, no, when we create a new lambda, we queue two aspects of the lambda to be processed later. And that just happens automatically. But if we find a matching polymorph, it's like, oh, we started creating that lambda, but we didn't really want to create it, so we have to unqueue it so it doesn't get compiled. It's a little bit messy, but and maybe at some point I can avoid queuing it until later, but that also seems complicated. So you know, whatever, man. So we're gonna do this, and we're gonna do this, and we're gonna do that. And is anything else happening in here? I deleted too much. Okay, this is good. This is a good simplification. And this is not cut and paste anymore. This is much, if I deleted these comments, this wouldn't be very much code now. Okay, this is good. Feel like I'm getting somewhere. And again, all these, that seems like a small, I mean, it was only, what, we just deleted 20 lines of code or at most. But it's an important 20 lines of code because, you know, they're code that's getting in the way of certain other things. And again, like I always say, complexity is super linear. So, you know, complexity breeds more complexity in the future. So when you can get rid of some now, it benefits you for a long time. Remove the separate find matching polymorph base for value bakes. That is good. That alone would be enough to make this a successful stream. No, the biggest files in the compiler are like 5,000 lines or something. The biggest file is, or 8,000. The biggest file is this one. It's 8,550 lines. But that counts new lines and comments, and this does not count new lines and comments. So, although we can see, so typer, it's only 5,600 lines of actual code. So, you know, it's not like any one file is most of the program. Although there are, you know, by the time you take like the top 8 or 9 files, that's most of it, much of it. You know, there's always this long tail thing that happens. Yes, okay. So now, I'm at a good place to be because I don't know what to do yet, because I succeeded at what I was trying to do as my short-term goal. My longer-term goal is to get rid of the two-phase thing that happens when you do value bakes. And so I'm going to start looking at how that happens and see if that's a place where I can make headway now. No, so the PCH is this. This is a stupid Visual Studio thing. The way you do precompiled headers in Visual Studio is you make a file that includes things, and then you say that the output of that file defines a certain precompiled header. That then, when other people include it, it's like the output of this thing. It's stupid, and this is the cleanest way to do it that I know of is just to make a file that's not real and just includes the thing that you actually want to be precompiled. Yeah, whatever. Whatever. I mean, yeah. Okay. Because that was so good, I've got a delicious candy bar that I will not eat yet, but I will leave here temptingly. Five-star peanut bar. These are really good. Five-star peanut bar. Five-star peanut bar. Okay. Now, right, so let's just kind of look for okay, this is the thing that applies the value bakes. This is not really, this is not going to be the point at which we simplify, but I'm going to look at it to refresh my memory. The place that we're going to have to edit is in typer.cpp. So we find for every value bake, the bake item is just a struct that has like the name and the expression value. So we find them. Maybe this can be simplified out eventually. By putting source decal. Maybe it can't be. It depends on how this is called. I believe it's called from at least two different places. No, when the parent function of this is called from at least two different places for value bakes. Oh, you know what? Okay, I was commenting on this during one of the streams yesterday, that I think this might work now. Although, there's actually, I said yesterday, hey, I should test that and maybe remove this. I don't think there's a way to test it yet, because the language yet is not good about constant structs. So like if I had a vector 3 that was constant and declared in a global space somewhere, like you can't really do that right now. And that using is something that you apply to structs. And so and the whole point of value bakes is to make something constant. So this would be exercising a path that the compiler doesn't really have yet. Except, well, we don't really deal with constant structs yet. So we don't enter into any case where we try to apply using, I think this code will work and constant structs work. I think said scenario will work, but I am leaving this in the code to remind me to test this case later on when when the case is case and the time comes. Not 265. All right. In general, it would be nice to have a stream. Looking back at demos features, maybe it's just, that would be a really long stream, man. Unless it was really cursory. Most of the things that I have demoed are still in the language. Many have undergone, improvements, but they tend not to be. Improvements that fundamentally change the nature of how things work. They tend to just be like, okay, we've simplified it, or we've handled more corner cases, or we've made it interoperate with some other thing, etc. The exception to that is SOA, which, as I said, is currently deprecated, but that's because there's a plan for something better. The other thing that'll probably happen to is iterators. Like when I demoed iterators, at the time I said I didn't like the way that it led to a lot of code, which is sort of one of the same problems that C++ has. And so iterators still work, like Sokoban uses them and stuff. They're not deprecated. And what'll happen with those is just the way that they work will be different, I believe. And that then, let me think. Oh, the other thing that's gone, in the very first demo, there was a check directive, like you say hash check, print, whatever. That has been removed simply because compile time execution now and code introspection is so powerful that it's just better to write those in your own metaprogram. So that was taken out just to simplify the compiler. But for the most part, everything that's demoed is still here and live and just improved. Have I ever thought about how somebody who doesn't want to use compile time execution would manage using this language? I don't think there's any problem. You don't have to use compile time execution if you don't want to. So, like, you can just use it like C or like a light C++ if you want, and there's not really any problem. And in fact, that's why. So the reason, for example, why I have these polymorphism features that I'm working on right now is because I don't want to require you to do compile time execution in order to do many classes of common things, right? I could have just said, hey man, I want to be like Scheme or something and have a very simple language kernel, and then you just use that language kernel to do what you want to do. So if you want to have polymorphism, then you build it on top of compile time execution, and the way you do that is you have a procedure that looks at your old code and gets the syntax tree and dorks around with the syntax tree and then resubmits it, right? And it's like, okay, but that's a lot of mess to do something that may happen many times. So, you saw how many times right now when I compile Sokoban that it spits out those polymorph matching things. If you had to run an execution job for each one of those, that would be slower, first of all. So, and then, it's just more complicated and stuff. So I am thinking all the time about making things convenient, right? So compile time execution is meant to be something that you only go and do if you really want to, if you really want to go there. Okay, and we have a little bit of 5-star peanut bar. Okay. So good. All right. So, what are we doing here? We find the declaration that we're trying to bake. We do that using tests that doesn't matter right now. And we find it in the types block, or no, in the arguments block. And then once we baked it, we can actually break here. There can only be one declaration of any given name in the arguments block. So that that still works. Whoops. That still works. All right. So this is really actually a pretty straightforward procedure that doesn't do a whole lot. All right. So that's good. We don't want it to do a whole lot. And we have the possibility maybe of simplifying it if, when we set up these bake items, we already know this declaration, then maybe we should just put it there. Let's now go, I believe, to typer. Here we go. Okay, so there's resolve potential value bakes. There's two cases that we need to look at. So when you call a procedure that has arguments declared as bake me, this gets called. And down here is a different thing. These bake items, oh no, wait, that's the same. This one is a bake directive, right? I don't think I use bake directives in Sokoban yet, but I do in that demo. So it might be that we can attack each of these separately. Or maybe this one doesn't need to be attacked. Let me see. So we set up the bake items. So we go through all the values. We set up the name. Okay, we don't actually look up the declaration in the Lambda at this time. Okay. So this is where it gets grody, right? So if it's a value bake, I call do polymorph with the bakes. That's fine. Here I do actually look up the things in the types block anyway, so maybe I should store those on the bake item. Yeah, anyway, I'll worry about that later. And this is the better place to signal the error anyway, because we have more context about what the user is trying to do, so we can produce better error messages like this one. Wait, what? This is totally redundant. This is just saying, oh God. This is grody. So this is, so you know, we have this abstraction that's like, look in the types block and give us the declaration, right? And the types block is just an array of declarations, plus a little bit of other stuff. So this gives us the declaration, but it doesn't give us what the index is in the array. So then we like find the index down here by iterating over the array again, which is, it's only 4 lines, but you know, whatever. It's only really 2 lines if you get rid of the asserts, but so anyway, if I want to simplify stuff, I don't really want to call this in 2 different modes, right? Especially this one looks really complicated, and this one looks really simple, but in theory they're doing the same thing, right? Like this one has some bake items, and it's saying bake this, and this one yeah, like I don't, so what I'm going to try to do is turn this into this, right, which will very much reduce the amount of code. And then I can just combine them into the same thing, hopefully, mostly. Because they're doing the same thing. They're just saying, like, look, here's what we want to bind things to in the types block. Although, like I said, maybe then we lose error context. Maybe we don't. Maybe we can. Oh. If we store the declaration on the bake item, right. Okay. So actually, so this loop body, I'm not really going to worry about yet. Because that's just looking up the items. What I'm going to worry about is this and this, right, getting unified with this. This already looks the same, but it's actually not, right? Because the arguments to do polymorph determine which of those 2 modes it operates in, right? And so this one is saying null for types block expressions and here for bakes, and this is saying this for types block expressions and null for bakes, right? So it's being called in 2 different modes, and that's gross, and that's what I want to get rid of. So we want to call them in the same mode. And the way I'm going to do that is by setting up bake items instead of doing this init types block expressions, which that is, I think, it looks like it's only, oh, it's called from 2 different places. So maybe we can't remove that yet. Although, maybe we will eventually, because yeah, I'm going to have to look at that. I sort of feel like by the time I'm done, fill types block expressions should not be a thing. There's a meta issue here, which is the following. These types block expressions, this types block expressions array is in the same order as the types block. So again, there is a speed benefit to that. And the question is if we can maintain the speed benefit without all the extra code. Like there's probably a good, at least 100 lines of code that could probably go away. And again, they're in one of the most complicated systems. So that would be a very good win to get rid of it. Okay, I'm going to take a 5-minute break and just rest my mind. And when I come back, I'm going to try to do something here and simplify this stuff. So, and when I simplify it, I feel like, again, the goal is not to worry about optimization, because frankly, this operation probably takes up very little of the compile time percentage-wise. So if it gets slower for a while, that's fine. And sometimes, you have to get slower to simplify, and then when you make it faster again, you make it faster in a better way. So, yeah. 5-minute break. When we come back, something will happen. Can't drag this. All right. Involving polymorph. Involving value-based stuff. Yeah, I feel like I want to push polymorph to be as simple as possible, not worrying about performance ramifications, because I don't think there are any in reality right now. And but then later on we can see. Do I have any advice on good compiler literature resources? The last time you were asked about it, you just mentioned what was not good, but you didn't really talk about actually good resources. I do not know any actually good resources for compiler development. It's not to say there aren't any, but I don't know any. There are some where if you kind of know what you're doing, then they help. Like the most modern compiler book that I know that you could kind of use as a reference or to find your way around is Andrew Appel's compiler books. I forget what those are called. He has like one that's in C and one that's in Python. Not compiling with continuations. So these ones, compiler implementation in Java and C and like Python or whatever. Now the downside of these is that the code is kind of crap because it's just straight transliteration between languages or something. It's not, the code examples are not that great, but you can use these books to get a good overview, but don't believe them about what's a good idea. Like, no book coming out of academia is going to tell you what's actually a good idea for implementing a compiler. But they are good for understanding the idea space. Yeah. So I guess there's a whole page here for these books. I mean, you know, and they're pretty old. They're from 1998, but that's still a lot newer than the frickin' Dragon book. So Andrew Appel is an ML guy, so this ML version was the original, but like probably nobody watching this stream programs in ML. So, and the problem is when you translate ML to C, it doesn't come out well. But yeah. So this is the closest to a recommendation, but it's not totally a recommendation. It's just like, well, you could learn some things from it. But it's not like take it as gospel. And like it's 20 years old at this point, and it's still, eh. Do I think there will be VR development environments, languages, or will be using keyboard text monitor for the foreseeable future? We are not even doing a good job of using a 2D monitor yet in terms of, you know, visualizing programs and stuff. So how is VR going to help if we're not even using 2D? Yeah. What is the best way to learn then? I don't know. Like in college, I just started making toy languages and playing around, and I just used whatever references were available. So, I mean, you just kind of have to muddle through, right? So there's a lot of things on the internet out there about how to do compilers. Most of them are probably terrible. Most of them are probably bad ideas. You know, the way I muddled through was I did the bad ideas, and by doing that, I learned that they were bad. So my first several toy languages that I made when I was in college, I used the compiler generation tools of the time. So I used like Lex and Yak, right? And they're terrible. And I thought they were good, and then I learned through experience, like, actually, you know, this is kind of terrible. And by the time I did like my fourth toy language or third or something, I was like, okay, you know what? The parser generator seems hard, but you know, I bet I could at least write the lexical analyzer myself, and it would be much simpler because it doesn't seem like a hard problem. And so I did that, right? And then later on, I was like, you know, I don't think this parser generator is really doing much for me either. I could just write a parser by hand and so on, right? So you just learn by doing things. It would be nice if there was a good reference out there. Like I said, I want to do handmade compiler at some point, but I sort of decided I want to do it in the new language here because I don't want to code anything non-trivial in C++ if I don't have to anymore. And so that'll have to wait, I think, until the language is publicly available. And I will try to make that a good reference. And apart from that, we'll see. Yeah, having a bigger monitor is not the problem with not being able to use the monitor to visualize your program. You know, this is a 4K monitor that I'm using right now. It's got a lot of pixels, and almost none of them are used. I mean, open Visual Studio, and look at how much of what is on the screen is crap that is not helping me, and how much of what is on the screen is just text like I had in 1989, right? With a little bit more syntax highlighting than I had in 1989. And then a lot of the active stuff that Microsoft does is just garbage. And like nothing here really helps me visualize my program. And the modes that they have, like class view and stuff, are just, you know, that's garbage. It's not useful. Team Explorer, I don't even know what the hell that is. I don't care. You can see my opinion on Rust by watching earlier videos in this stream, like the first couple. Okay, I'm taking a break, and I will be back. it's time to start up again. What do you think of the bare minimum parser Casey made at some point on a stream? I did not see that, so I don't know what to think about it. What makes a good game? That's complicated, what makes a good game. There are many factors. That's all I can say. As I said earlier in this stream, SOA and AOS are currently deprecated features in the language, and it's not because they're not useful. It's because there's going to be a better way to do them that hopefully will not complicate the internals of the compiler as much as well. So I'm letting them break right now in order to be able to simplify stuff in the compiler, and they'll be replaced by a new feature later. So because I know that they're deprecated, I'm not trying to use them right now. But I'm structuring the engine for Sokoban to be able to use them. So when I set up like entity creation and stuff, I'm factoring them into pieces so that like the hot piece can be SOA in a certain way, and that'll be good, for example. That'll be, maybe it'll be a good demo after the new feature comes online to like step through Sokoban and show how it's used at that time. However, that'll be in a little while. Will I share the code of the compiler in the future? Yes. That is the plan. When it's ready, yes. And it's closer to being ready than it ever has been, but it's not yet ready. So, how do you make a puzzle? Well, you watch this, and we explain for an hour how we make a puzzle, me and Mark. That's the most thorough reference that I know of. Actually, then there's also this, which was a panel with me and Mark and Draken in 2013. It's unreleased, so you haven't played it. He also made this game, Yegakure, which is about understanding the fourth dimension and getting blocks where you want them to go. It's also unreleased, so you probably haven't played it unless you played it here like 2 or 3 years ago. Yeah, so those are my opinion on how to make puzzles. Okay, so let's try to do something here. I want to set up bake items. I already have bake items. I think, no, I don't. Maybe, so up here is where I set up the bake items. Like, why don't I just try this? Like, I want to know what happens if I just do that. I feel like this ought to work, but, there's always reasons why maybe it doesn't. See what happens. Let's try it on the demo first. Okay. Oh, it's because, okay. The reason it's not working right now is not an inherent problem. It doesn't mean there aren't inherent problems, but it's due to the fact that the callee is still doing this in two phases, right? So it's saying before we bake the tea, before we apply the bakes, it's like, well, the non-bakes had better be solidified, right? So let me look at that test, right? We in fact are specifying it, obviously, right? But it's still thinking that it should be called in a different way. Let me just see. So this error anyway should happen after the bakes get applied now, right? So it was happening before the bakes get applied. So if we send this in as a bake, then obviously it's not going to work, right? So we'll move it later. Okay. Now in value bake, parameter t is not found. Really? Oh, parameter t. Right. Right. Okay. Okay. So it's when we send stuff in as bakes, it believes that it always should remove a parameter from the procedure that has that name. And now maybe what we want to do is just put a Boolean that says we could put a Boolean on each bake variable itself. Each bake item. And that Boolean can say, yes, this bake item is supposed to remove something from the procedure, or no, it's not. Now, that's going to, again, affect the implementation a little bit, because if you recall from yesterday's stream, I had tried to make it so that we don't transplant a declaration from the procedure arguments into the types block, but we do that now. But maybe we shouldn't ever do that anyway. And just transplant the identifier. Do I like that plan? Do I like that plan? So I would flag the bake items depending on what type of bake directive there is. There's two kinds of bake directives. There's one to bake the type arguments and one to bake the value arguments. Eventually, this simplification should propagate so far up that we can kill one of those types of bake directives and only have one, which will be awesome, because it simplifies the language semantic, right? So that's good. So I want to work toward that. So for now, I would flag the bake items depending on whether they're supposed to remove a procedure argument. Yeah. So I like that. Now, what I'm going to do is I'm going to roll back to a working program, and then I'm going to work on that implementation of the parameter movement so that it should work in both ways. Whoops. And once that works with the working program, then I'll try again what I just did. So, working program. All right. I'm not sure if I made any changes, so checkpoint for coming thing. All right. So, let's look at the declaration of bake item. So it's just got an identifier and a value, and we will say bool I want to come up with a good name. Like, is it a parameter? I'll just call it should remove argument by this name. And for now, that'll always be true, because the only times we ever use bake items are for arguments. And then I want to go back and look for this. What was the error message? Okay, in value bake, parameter, etc. That's polymorph.cpp 364. In value bake, parameter, whatever is not found. Okay, so this is our old loop that we've been looking at a few times here. And we want to only do this if the bake item, what was that? Struct this variable, which I'm going to put the name conveniently over here because we're going to want to use it. Okay. Why is that not indented? I don't know. Emacs, Emacs. Da, da, da. Okay. So here's what we're going to do. So the function of this is just going to be to find that argument and remove it. And then down here, we're going to say well, if we have the arg decal, we do this stuff. Else, we got to make a new declaration. We assert that we have a new declaration, and then we add that to the types block. And actually, all this stuff okay. Let's go get our handy variable name. So if we said that, what's our bake item called? It's ridiculous. I don't know how the precedence goes there, whatever. So if we should remove the argument by this name, then we assert that we found we just do that right after the loop. If argdecal new decal equals argdecal. Although, you know, because we're removing this up here, so it makes sense to just put that up there. Else. So does bake have an identifier? Yes. Copy location info is used for error reporting, not indentifier. It's the name of my new band, Indentifier. All right. So we make a new declaration. Otherwise, God only knows if I need to flag that in some other way, but we'll see. You know what? Instead of having all these extra all right, that's easier to understand. Okay, so I've added all this code. This is not even going to get invoked yet. Let's just make sure this works. And then we'll baby step it. No, should remove. This is bake arrow that. That worked. That worked. Okay, good. Okay. Now, so this is never getting invoked because our value bakes never have this set to false yet. That's fine. So now all this stuff, okay, we'll move this up to the top. Wait. No, we can't move to the top because that's that. Okay, so we only do all this stuff if we should remove an argument by name. All this stuff. All this stuff. All this stuff. Right? So if we're not removing an argument, we just start here and go down. That's good. I like that compartmentalization of that complexity. Oh yeah, I got to move the declaration of this upwards. I was thinking I needed to do that, and then I spaced on it. So that needs to go outside there. All right. Yeah. Okay, this is good. So what this has done is prepped us to be able to pass in value bakes with that Boolean set to false. Right, okay. Maybe now we can pass in value bakes that don't remove arguments. Cool, so now we go into typer and redo this thing. If I thought I was going to toggle this a lot, I would put an if-def around it. But I'm being optimistic that I won't have to do that very many times. Maybe it'll do something. Oh, really? Oh, because I don't set the right. So I have to set that flag to false. Otherwise, obviously, it's not going to work. So item dot whatever is false. Right? If it's just a polymorph variable thing, yeah. Yeah, all right. It's both redeclared and not specified. That's weird. Oh, right. Okay. So I'm making a new declaration, but I don't want to make a new declaration, right? It's fine because I didn't spend much effort on that. But so this thing here, I said, okay, if we didn't get a declaration from the parameters block to move to the types block, make a new one. But actually, we don't want to make a new one. What we want to do is fill in the item that is in the types block. So we want to say new decl equals find in block bake ident. We want to find the thing using this identifier in lambda types block, right? And if we didn't find that, then that's some kind of internal compiler error. For now, internal compiler error did not find an identifier by this name in the types block. And we just return. Okay. So its identifier will already be set. We don't have to do any of that. And this is a little bit of an unsavory thing. Like, what else? I should maybe make an abstraction for this, but ba-dum, ba-dum, bum, bum. Ba-dum, ba-dum, bum. I don't even remember this one. All right, that's going to be interesting when I try to simplify that. Defining block, oh, it's atom and not ident. So okay, cool. What's going to happen now? Still a redeclaration. Well, we've got only, we had 2 errors before and only 1 now. So that's good. Well, I can put a breakpoint at that error message, and I can see who is. Wait, oh, wait. Okay, no. If we found it in the types block, then we don't add it to the scope because it's already in the scope because we found it. Duh, right? I'm gonna do this because this is an important assignment, so I'm gonna put it down there so it's easy to spot. Okay, so okay, that all makes sense to me. That all makes sense to me. Yeah. Okay, that is major. That is major. That is Major Havoc, the video game from the 80s. Okay, that means we can go here and delete. Oh yeah, that's so good. Now that's still one of about 10 such simplifications that I probably need to do, but it's fine. Because that infrastructure that I just did will probably help with the other 9. That's great. So we do this and assert poly lambda probably. Look how much simpler that whole thing got. Of course, we traded that off with a little bit of complexity in the lower level routine, but it wasn't much. And we're going to be able to use that at all the calling sites. Okay. Okay, so I didn't remember what the number of lines is that we had before, but we got rid of at least, I don't know, 10. Who knows? Maybe we added some, but it's logically simpler. That is so good. Like, I can actually look at this and understand what it does now. So I think the next thing to do, I'm going to take another brain break for a few minutes, but the next thing to do will be to look at the other thing in this file that creates value bakes and see if I can pass it down in the same way. Which one of these buffers? No, not that one. Not that one. Yes, this one. So I'm going to take another short break. And we will come back. This is good because this is like the most complicated part of the compiler. So every simplification that happens is a big help. And like I said, this is eventually going to percolate all the way up to having there only be one type of bake directive, which would be great because it felt wrong to me to have two originally, but I didn't understand how to do it better, and now I do, so that's great. People are talking about some probability thing in chat that I haven't been following, so I don't know what they're saying. Ooh. The developer supporting servers for reporting servers for Steam are having problems. Oh, there we go. There we go. All right. I get so many spams now from people who are like, trying to PR games on Steam. Report spam. Report spam. Delete, delete, delete. Mail from Sony I should probably pay attention to today. Spam. Okay. I've knocked out a few emails. Are there any questions about what is going on? Or should I just forge ahead into the wild unknown? Wow, I've eaten almost this entire peanut bar. Good thing I threw away the outer wrapper, so I don't know how many calories it is. I think it's like 400. $400 peanut bars. 1,000 million peanut bars. Have I heard of the CS School 42? No, I don't know what that is. The Cliff Note summary is I'm trying to simplify the polymorphism system any way that I can. And we're doing it, we're proceeding in small steps because it's a very complicated system. But it's getting less complicated as time goes on. It's getting less complicated as time goes on. Man. Okay, this thing that submits bake items just goes through the old path. So I don't think there's anything to do there. Like ideally, so I think my goal now is the following. To make sure this second argument to do polymorph is null at all times. Right? If I can do that, then that'll simplify a lot of things. I always want to pass bakes and not this. That is my current conclusion. So let's just look at calls to do polymorph. Okay, here's one. Where is this? Okay, make polymorph of called procedure. So if we can make that just take bakes, bake items, then we can fuse that together with something else that we'll look at. So that's the declaration of the procedure. This one, maybe we'll attack this one next. Where are we here? This looks a lot like what type check arguments helper. Like, this is weird that all this is happening out here. Yeah, like, all right. This one is null and this one is null. So we have two calls to do polymorph that use this types block expressions stuff. And if we can get rid of that, then we can get rid of fill types block expressions and any other things. Okay, that's fine. And so all the calls to this, no, okay, one of the calls that we need to do is this one in typer, and one is in this one in polymorph.cpp. Let's look at that one, because I feel that it is, oops. I feel that's a relatively understandable I feel like this is a very understandable thing, right? This is just what happens when you pass arguments to a regular polymorphic procedure. You're not doing a funny bake or anything. So we want to turn these into bake items and submit the bake items so that that second argument can be null. So that's the loop solver stuff. We do the loop solver, and now we do this. So this is the thing that we want to change. Everything from here to there. It's not a lot. Let's look at what fill types block expressions is, because I want to see why this yields. That's important. Oops. So, it doesn't yield right now. Right? Well, let's fix that. Even though we might delete this eventually. Okay, I'm going to put a simplify me here so I can find it. This thing doesn't use yield upon. Oh yeah, it does. So when does this happen? So it's if we have an expression in the matches and it's a struct and the struct is not far enough along that we know that we have all its members. Then we need to yield and we're not ready to do that. I feel like that maybe is something that shouldn't be done here. It should be done by the caller anyway. Like when you put together your matches, you check it. Who messes around with polymorph match? Shut up, Creative Cloud. I don't care. Exit. Settings. Preferences. Don't launch. Don't show notifications. Don't stay up to date. I don't care. Die in a fire. Okay. That's all you need for programming productivity is to have 10 programs like that bugging you every day. All right. Now I don't remember what I was doing. I lost my train of thought. Okay. I want to move the yielding out to the caller. Let me search for polymorph match in a case-sensitive way. In a case-sensitive way. All right. Still a lot of them, but I have a feeling it's a relatively few sites that use this. It's like, looks like 3 or 4 places. Oh, these are commented out. Let's delete those. That's the declaration of the struct. This is just here. Check for duplicates. That's fine. That's fine. Solve for matches. This might be a good place to put the yield. Yeah. Well, I mean, it's a little weird because then we have to check for yields in like 5 or 6 places. But the good thing about that is if we yield, we don't keep allocating other polymorph matches and then yields later. Oh. Instead of so all this yielding thing only happens because this language doesn't have header files or compilation order. So this is one of those complexities that wouldn't exist if this was C++, right? So yeah, and the reason I'm trying to get rid of this yield is that we need to preserve the functionality of the yield even if we get rid of this fill types block expressions because we need to yield. You know, since I don't care about speed right now, I can factor it out into a separate. Every time I call fill types block expressions, I can say check for yield on the array of polymorph matches. That's what I'm going to do. Because I don't care about speed right now, and maybe never because n is low on these. N is low. Okay, so I'm going to say void check for yield. Which arguments do I need? I don't know yet. I'm just going to copy them all. And I'm going to say, go over the matches. And that'll simplify. See, that looks nice and simple now. Doesn't it? And we can just get rid of this. Get rid of that. Get rid of that. Like, this looks understandable now. I'm not sure. Yeah. So all this does is it takes things out of the order of however we matched these matches and puts them in the order of the types block, which if we convert everything to bakes, we don't need that reordering anyway. So check for yield, and I'll say if it's not a type, we continue. Okay, So now every time we call fill types block expressions, so we don't need interp here. We don't need expressions. We don't need types block, right? We just need this. Maybe. Where's the error? Interp undeclared identifier. Oh, right. That's kind of dumb, but whatever. Okay. So now, check for yield. Interp matches yield upon. And you know, maybe this should be, maybe check for yield should be implicit in self or matches, I don't know. Okay, so now our simplify me is a smaller spot, which is good. Now, we were calling this from some other file, I think polymorph.c. Fill types block expressions, or in typer. Yeah, we're calling it there. So we got to get that one as well. And that doesn't have this argument anymore. And check for yield, interp, yield upon. Okay. I need the prototype for check for yield. I need that. Because it's C++. The work that I'm doing right now in checking for yield means that you don't have to do this in this language. All right, and we get rid of that. That all sounds plausible to me. Compiled. See what happens. I might have done something bad. No. Yes, all right, this is good. This is good. There's no way Sokoban would have compiled if I wasn't yielding properly. It would be a disaster. Okay, factor check for yield into its own routine. Everybody's talking about random float generation in chat. It's the topic of the day. Wow, it's 10:30 already, which is usually the start of my workday, and I've got some things done. Okay, so let's go back to the simplify me. It's not really going to be simplified anymore. It's going to be, because this is pretty simple, it's, we are converting what we're doing to the new, or the bake path, the value bake path. So I'm going to go bake item array bake item items. I don't know. I don't use this macro enough. Okay, that compiled. That's fine. For every solution, okay. So instead of doing all this, we're going to do this. We're going to fill out the bake items. We're going to pass null for this argument, and we're going to say items. Okay, so every bake item there's no argument corresponding to this name because it's a type parameter bake. Item.ident equals what's it called? It.ident item.value equals like a polymorph match and a bake item are not that far from being the same thing, so maybe at some point those will be here. I'm just converting between two things that are basically the same thing. All right. Where's the error? Value is not a member of polymorph match. Expression. Okay. Sukaban did not compile. Let's see if the simpler program generates an error so you understand. Okay. Okay. This is, okay. So when you call something that has no arguments like this, and then the modify procedure, I demoed this way back, the modify procedure generates the value of t. We're probably not invoking that modify procedure if we pass value bakes. The problem is, I may have to put in a temporary hack for that. Because I'm not sure we want to invoke it all the time, because if we're still doing two-phase polymorph at procedure call time, which we are, we don't want to run the modify procedure twice. Maybe we do, maybe it's fine. It seems complicated. Okay, so that's the bug there. Let's see if there's a different one in Sokoban. It's matching two overloads. In line 35 and 56. Okay, so again, it's a modify procedure not running, right? So here's the thing. So when I'm serializing stuff, I say like, look, if it's a string, just do this one, right? And only this overload matches because if you try to apply this with a string, it says, okay, it's not one of these types, so reject it, you know? it's, both of these are down to modify procs not being run. So we got to go into polymorph. So someone is asking, why has it emerged that bake item and polymorph match are the same? Is it superficial or a more fundamental truth? It is a more fundamental truth. Polymorph match is what you get. You know, if you're just going to call a polymorphic procedure with some arguments randomly, then the polymorph is what match is what says, oh, T is float or something, right? And then the bake item is just says, hey, bake this item T as float. It's basically the same information, and the reason that they are different is probably historical. It's probably just the way that I implemented things. And so, you know, again, putting those together into one thing will probably be a good simplification. But I'm not, you know, that would be a little bit later. It's not as important as getting the code down, the number of cases down. Will random eventually call a random number generated from the context parameter? It's a good question. Now that, so I wouldn't have felt necessarily like it's that good of an idea to have a global random number generator, but once it's in context, and once you have expandable context anyway, and could put a different generator there if you want, which we have now, I don't see why not. Like, it seems fine to do that. Will there be a way to label a function as being context-free? Yes, there will. I think there already is. Don't I have a... Okay, so I have this internal flag that lambda has no context argument, and I think, I'm not sure if I added a way to syntactically set that. It does get invoked, so when you declare something as a C callback right now, like the calling convention, to call into the procedure has to match C, so that, like, hey, Windows, here's my window proc, right? So that already works, and that sets this flag. But it also changes the rest of the calling convention for the procedure. So I don't know if there's a way to flag this right now without doing that, but there will be, probably. Okay, wow, I ate the whole peanut bar. We're doing good for snacks today, or bad, depending on how. Okay, so do polymorph. Yeah, so we only apply modified directives if we're passing in these types block expressions, which is a thing that we're going to get rid of. Now, the scary thing is, okay, I should look at what the rest of this stuff is, because I'm implicitly not running this stuff either on these things that I'm changing to use the other pathway. So this is just an output string for, like, when we're outputting okay. Before I keep, let me go back and switch it to a working program again, and we'll checkpoint where we are. Where were we? Were we in here? So we were doing a check for yields. Like, this is totally redundant with the other. Like, why is that even? All right. There's just a bunch of code that needs to be sandwiched down. Okay, it must have been, I must have been over in this file. No? I was here. Okay. For some reason, it didn't register in my brain. So we're going to toggle this back. Well, so we're just going to check this in for further experimentation purposes. Okay. Am I still taking email at that email address? Yes, I am. All right. What was I doing? I was going in, okay. Run, modify, apply, modify directives. Okay, so we're only modifying calling modify directives in the case of types block expressions. I want to say, oh, all right. Okay, let's factor out the question of running the load directive into a separate thing. So we'll say run load directive is false if run load directive, no, run modify directives, not load directives. The load directive is something given back to us when we do that. So there, 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 there. Okay, so now we're going to say that. So this should still be unchanged. And then what we're going to do is we're going to do a hackety hack where we ask if any of our bakes are if any of our bakes are types block bakes. Yeah. And that's a thing that'll be a temporary thing that we remove later, but it'll help us transition to where we're trying to go. Okay. This is good. This is good progress. All right, so we are going to say if we have value bakes, which eventually this will always be true. So we can remove this test. This is the thorn that removes the thorn. This is a temporary measure to keep behavior the same while we factor code together. We should be able to do it later. Okay. Yeah, I don't. Okay. I'm just going to do the old style C iteration here, because why not? If it's ever equal to true, then we are doing the type thing. It's so I probably should run modify procs always, no matter what. The only potential problem is just that, like I said, this is being called twice in some cases of procedure evaluation if there are polymorph variables and bakes. Which is definitely something I should explicitly test later. And if I do that, and if I run the modify proc twice, it might be bad. It might not even be bad enough to avoid it this time, but I'm being paranoid a little bit. Okay, so we just look for something and set that to true. Right, that should not change any of our current behavior because we're not doing it yet. 499. Yet another thing that I don't have to worry about in my language. C++. C++. Okay, so that's good. And that's good. All right. So let's try it. If this doesn't work, we'll check in. Is try me here? No, it's in the other file. Where's try me? Here we go. What happens if we try me? We got to recompile. Try me. It didn't work. Why didn't it work? Oh, no, because I did the wrong check. It's supposed to be if it's equal to false. If it's equal to false. Okay, well, we got a crash. That's exciting, I guess. Why did we get a crash? Oh, geez. Run modified directive. Yeah, it takes a types block expressions. Yeah, okay. See, this is part of the pain in the butt. This is part of the pain in the butt. Pain in the membrane. So, I should have noticed that we're passing types block expressions to this, and that should have red flagged, but I didn't. So basically, when we run a modify procedure, what the point of that procedure is, hey, take the old expressions and pass them in as those values, and then see if the modify procedure changes any of the expressions. The place that we got the old expressions from is this types block expressions array, and we want to maybe get rid of that, except I'm not sure. See, I'm not. I'm not sure this is the right way to do modify, honestly, anymore. So what this was doing before was it was running the modify before binding the values in the block. But binding the values in the block is a very lightweight operation. So why don't we just bind the values in the block and call the modify and see if they change, maybe. So what I think the right thing to do is, that's why this is, there's so many tendrils of this system that touch other things. It's why simplifying it is valuable, because stuff like this happens. There's an interaction between the system that runs modify procedures and the system that decides what to polymorph how. So I think the thing to do is we toggle that define again so that we're back at a working program, check that in, and then start messing around with this. So this is just like, and it might be more efficient anyway to just have the stuff in the types block. So what this is doing is it's making an array of what all the expressions should be. That's the same size as what's in the types block, which, by the way, is ignorant of any value bakes. So what this means is you can't run a modify proc on value bakes, which is probably bad. That doesn't seem like a good thing. And it was something that I was aware of, like, oh, back when I did this, I was like, oh, this won't work, and sometime in the future I should fix that. And so we're coming to that time. So really, in whatever way I fix this, it should generally handle everything the same, which of course is my objective behind this whole cleanup. So, we're setting up a call for a compile time bytecode procedure, because that's what the modify proc is. For all the arguments to the modify proc, we do a bunch of stuff. And we just get the expression out of this argument expressions array that we built up here, right? We're adding stuff to argument expressions in order of types block, etc. So really we can do that just a different way. The problem is, like, if I want to do this step by step, I sort of would need to keep this version and a new version and then delete this version briefly. So it would get real ugly for a little bit. But that I think that's all that we use the types block expressions for. Let me go check that. So here we have run modify directive, we have types block expressions. Or I can take two parameters here, one for types block expressions and one for bakes, and do it that way for now. That might be a better intermediate way. So we're already assuming here that the arguments and the types block expressions are in the same order. Wait, what? How is that a thing? Oh, is this the modify lambda and not the, no. Yeah, okay, yeah, this is the modify proc. This is the modify proc. I'm not convinced this is right. I mean, it apparently works, but man, I feel like it's wrong. This is another good reason to simplify it. Okay, so those types block expressions, no, it doesn't. Oh, we use it as an output value as well here. Right. Right. I think we should just store these expressions. We should just, like, we should do the poking of the values into the types block first. They're already at that point in a well-defined order, and then we do this modify proc stuff. So that's what I'm going to do. So let's change this back to 0 and check in. Whoa. All right. It's crashing because of the other, yeah. Yeah, this is what happens when you have many features in your language. They interact. That's good, but it also makes it sometimes more of a challenge to change things. So I think the next thing is challenging enough that I may take a long break, because I've been streaming for a few hours today already, and that's a lot. But I feel like this functionality is something that I should just stream till it's done. So I may take a break and do other things for a while. But I think when I come back from the break, the goal is going to be to move this running of modified directives down to way down to here. The goal is to move the running of modified directives to here. Right, so then we run the modify, and then we search for a matching polymorph, and so on. And because we've moved it to here, the types block is already assembled in order. You know what, I might as well start this and then take a break. I really want to take a break, but what does this do? And this pokes expressions into the destination types block. Which is fine. So the way this is going to work is going to be different. Yeah. It's going to poke things into the destination types block. This stuff is all going to go down here. Now, I'm going to get rid of that because that procedure is not allowed to use that for read-write at all. Yeah. Yeah, that's about right. Am I still in the San Francisco Bay Area? I live in Seattle most of the time, some of the time, and I head back to San Francisco about once a month to visit the office. Just think about the abusement that every C++ lunatic is suffering from watching this code. Oh, you mean like the modern C++ people? Is that what you mean? Yeah, I'm sure that they are looking at this and shaking their heads. Someone's asking, are polymorphic procedures dynamic or static binding? I'm not exactly sure if I know what you mean. If you mean like, as in lexical or dynamic scope, they're lexically scoped. For sure, yeah. Dynamic scope is weird. If you mean, do they get bound at compile time or do they get bound at runtime? They get bound at compile time. There's no such thing as runtime generation of polymorphic procedures. What is my opinion of the latest trend in using web frameworks to create desktop apps such as Electron? I'm of the opinion that someday maybe this generation of web programmers will figure out how to write software that makes computers better instead of worse, but they haven't figured it out yet. And they're not showing any signs of figuring it out anytime soon. Yeah, auto was introduced in C++ 11, I think. Hey, I know how to make I know how to make software better on the desktop. Let's make it unreliable and crappy and slow like the web, and then that'll be great. Because the web is cool. It's the web. As seen in Mondo 2000 and Wired. Everything is the future. It's the cyberpunk future of the electron web. People are saying mic volume is too low. It seemed fine yesterday. It looks fine. I don't know. The bar's going up pretty far. There's no, like there's, yeah. Oh, you know what? Can I turn this thingy? I don't know if that did anything. All right. So let me make an attempt before I go on break. I'm a little, yeah. This is C++, so I have to do this. Okay. So this just goes away. And running a modified directive shall now get the expression out of the types block itself because it's already there. So now I go to bytecode runner, get rid of this. And get rid of this. And so now is the hard part. It's maybe not that hard though. For every argument in the lambda, we have an arg decal, we have the name. Now, auto types block decal equals find in block interp name comma types block. I think this would be an internal compiler error. Our decal internal compiler error. When running modify, I'm trying to run argument is not found in the types block. Return false. So we have the types block decal, and then auto expr equals types block decal expression. And then to write back into the types block, yeah, we need to say what index each of those was. Array, int, argument, expression, index within types block. So these are two parallel arrays. Oh, wait. Right. Yeah. This is a little weird. So again, eventually, we probably want to let modify procs modify scalar values and stuff. But again, because of the way it was historically programmed, they only operate on types. So here we're saying, like, okay, if we found something in the types block and it's a type, then put it in the list, otherwise put null in the list. So that is not going to be good if we ever have a modified proc on something with an auto bake, but we'll cross that bridge when we come to it. It'll be fine at that point. We'll just simplify this to pass the right expression in there. So again, I have to do that same hack that we saw elsewhere for now. Rule found equals types block members dot find types block decal and types decal index hack cleanup assert found assert decal index is 0. Okay. So now we go to all this stuff. Let's assert that these are the same length. Okay, we call the modify proc. We do a bunch of stuff. Probably something here is going to break. Anyway, so we get down here, and this is the place where we were going to write back to that types block expressions array, and instead we want to say index equals sub I assert index is greater than or equal to 0. Auto types block decal equals types block members of index types block decal. Well, we gotta set this. Okay, that is a thing. Apply modified directives does not take 6 arguments. No, it doesn't. Where is this? This is for struct polymorph, isn't it? Oh God, I didn't think about that. I didn't think about struct polymorph, but That is not great. Actually, maybe it's fine. I may have to punt on this for a while. This is a whole other thing, by the way. After all this other simplification happens, the other simplification that needs to happen is that struct polymorph needs to be a lot more in common with procedure polymorph. So for example, we handle varargs in struct polymorph just fine, but we don't in procedure polymorph, and that's dumb. Like, they should be mostly the same code. So, okay, this now has a problem where I wonder if I'm using that in the standard library or anything, and it's going to be totally destroyed if I turn it off for a bit. Okay. I am going to postpone this till after the break, because the problem that I have now... No, you know what I'm going to do? Here's what I'm going to do. I'm going to say, until we handle this, structs can't do modify directives, because I don't think... Okay. Attempt to use a modified directive on a struct, but this is broken until we are done with the polymorphism cleanup. Temporary, turn null, don't do this. Incomplete. All modified directives. Again. Okay, well, that's something. Let's see what it's complaining about. Oh. Okay, this is something that started null. Right. Okay, the conditions under which I set this to -1 are not right. So if something starts null, like it's a return value polymorphism, so it doesn't have any declaration prior to running the modify, we still want to know its index within the types block. that is important. So really we want to just add the index no matter what, honestly. Blue. Hey. Oh my God, I can't believe it's working. So that was a relatively serious change. That was the kind of change that can really break something, but it didn't. I mean, we lost struct modifies, but I don't use those yet in the main program. This is awesome. I was thinking, this is complicated enough that I better punt on it till after a break, but went for it, and it's totally good. So this is great. This is great. This is great. So now that's going to be all that I do for now. When I come back after the break of a couple hours maybe or less, what is the next step? I always like to have the next step in mind so I can think about it subconsciously and all that stuff. I think the next step is back in polymorph.cpp. We had our try me, right? And okay, so this didn't work because we were requiring, to run a modified directive ever, we were requiring this types block expressions to exist, and that is no longer, oh wait, dude, what am I doing? So this were in the wrong order anyway, so that would have never worked. C++ preprocessor, it's annoying. Wow. Wow, Bob, wow. Oh my gosh. Okay, so this is pretty crazy. This is good. Okay, that didn't work. Okay, well that's going to be, when I get back, I'm going to start by figuring out why that doesn't work. And that'll probably be a very straightforward thing, I think. But I'm not sure. But Sokoban ran, are you kidding me? So that's very, very good progress. What this means is we can almost delete the try me equals 0 case, right? We can almost delete this, which was one of the only 2 times that we pass these types block expressions, right? And gives us a blueprint for attacking the other one as well. And then once we hit both of those, then we can simplify do polymorph. It's going to be all good, and then maybe we can get rid of fill types block expressions. It's going to be really good. It's going to be really good. It's going to be really good. Yes. Okay. So the objective when I come back is going to be low-hanging objective of just hit this and make it work so we can check in. What is the difference between type and type info? So a type is an actual, type is what you would expect. It's what the compiler thinks is the type of a thing. Type info is a struct that tells you about the type. And it's not really the same thing. It's kind of almost feels like the same thing, but how to explain why it's not? I mean, I've thought about trying to unify them into the same thing, but it's unclear. So first of all, if you're compiling in embedded mode and you don't want to generate all this type info for your program and store it in the data segment of the executable, you could turn that off and then you don't get type infos at runtime. You only get them at compile time. Whereas type like always works at both compile time and runtime. So that's one difference. You know, you can declare a type info struct and fill it out as a user. It doesn't create a new type when you do that, but there's various reasons, I guess, why you might want to do that from user level. So like if you're deserializing something, and the serializer wants to know the type info struct of things in order to, you know what the format is to decode the bits, then, you know, you could give it a type info struct that came from an actual type in your program, or you could give it one that you synthesize, right, etc. So they're different. God, Steam, stop it. I don't want to know who is playing what. So both of those are, it's just to say, I'm thinking in the background about how to maybe make it more like both of those are the same thing. But it's not that important of a concern. Like stuff like this, simplifying this polymorphism stuff is a much bigger concern for me right now than that kind of thing. How can you store type as a struct then? Is it internally just type info? No. Type internally is the following. You've probably seen in these streams as type definition, right? You've seen these maybe floating around. This giant mambo jumbo with all this information is what a type is. You know, it's what the compiler stores as a type. Obviously, none of this is there during your program's runtime, right? In that case, if you evaluate a type, it's essentially just an integer. When you compare a type versus another type, at runtime, they're just two integers, and in fact, probably at compile time as well. But that integer represents one of these guys. The type info is like an exported, simplified version of this that doesn't have any of the internal implementation details, because you don't want type. Type info is in sort of an interface or an API with the user, right? And so you don't want that to change every time you change implementation details of your compiler, or else, you know, you'll break everybody's programs all the time, and that's no good. So type info being a separate format from this is like a way of having hygiene between the way the compiler does things and the way the users do things. Yeah, C is, I agree. I think C is viable to program things in, like compilers and stuff. I know people who prefer to program in C over C++, even like the light C++ that I use. I don't use that many C++ features. And I know people that don't use any of those features at all, so yeah. Someone says, once you're done with polymorphism, is that the last big thing, or are you on to the list of smaller features you said you were leaving till the end? It is not the last big thing, but both of the last big things that I have in mind build on polymorphism to make bigger features, right? And so that's why I'm hitting polymorphism now, is I'm simplifying the core of it and making it stronger so that I can build these last two big features on top of it, and they'll be relatively easy to implement. We'll see how that plan goes. Is there anywhere to read more about the planned feature set of the language? Unfortunately not. Like, it takes enough of my time programming all the things I'm supposed to program all day. So I don't have time to document future plans. All right, I'm taking a break. We'll be back sometime in the future. See you.